numbers. We're going to start off with some vocabulary. So the first word we're going to talk about is natural numbers. This is going to be kind of weird, but I want you to, in your head, count to 10. You would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so naturally, you started with 1. Natural numbers are going to be those counting numbers. They're going to start at 1 and keep on going to infinity. And they're all going to be those nice numbers, 1, 2, 3. Notice you didn't naturally say 1.5. You said 1, 2, 3, 4, 5. And so those are going to be your natural numbers. 0 is not a natural number. Neither is -4 or 1.5 or anything like that. So natural numbers are your counting numbers. Next one, whole numbers, is going to be all of natural numbers, but you're going to add 0. So it's going to be 0, 1, 2, 3, 4, 5, etc. So natural numbers and whole numbers are very similar to each other, but natural numbers start at 1, whole numbers start at 0. So a non-example for a whole number would be like -1 or 2.3 or numbers like that aren't nice numbers per se. Now we're going to go to integers. So an integer is any number that you would traditionally put on your number line. So think back when you had to write your number line, you'd write -3, -2, -1, 0, 1, 2, and 3. These are the numbers that are integers. There's no decimal points at all, but it does include the negatives. So -57, for instance, would be an integer. 0 is still an integer, but 0 is also a whole number and a natural number. An integer would be like 1 million, or a number like 12/3. Now you're looking at this and saying, well, I wouldn't put 12/3 on the number line, but you actually do. 12/3 is 4, so 4 would go on the number line. So you want to simplify it first before you ask yourself, is this an integer? Numbers that are not on the number line like that would be like -0.3 or a fraction 1/7 that doesn't simplify, or a square root like the square root of 42. The next one we're going to do is rational numbers. So rational numbers are numbers that can be written as a fraction. As a fraction or as a ratio of two integers. So numbers that can be written as a ratio or a fraction of two integers. So for instance, 1/3 is a rational number because it is a ratio of two integers. 42 would be a rational number because you can write it as a ratio of two integers. Now that would maybe be 42/1, but it reduces to 42. So all integers, whole numbers, and natural numbers are rational numbers. But numbers that aren't integers, wholes, or naturals would be also considered rational if they can be written as a fraction. Now, 0.54. That is not a fraction right now, but it could be written as a fraction because it could be 54/100. So decimal points are rational numbers sometimes. 0.6 repeating is a decimal. It goes on for forever, but that's also known as 2/3. That is rational. Decimal points that are not rational would be ones that cannot be written as a fraction. So ones that continue on for forever and have this like 0.0100100001. There's a pattern there, but we can't write that as a fraction. Another one would be like just random, like 0.2493, blah, 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 blah. It keeps on going for forever, but it doesn't follow a consistent pattern and cannot be written as a fraction. The square root of 7 cannot be written as a fraction. Numbers like pi cannot be written as a fraction, so they are not rational. So then you're asking, well, what's the next step? And then that would be irrational. So irrational numbers are numbers that cannot be written as a ratio of two integers. So cannot be written as a ratio of two integers. So basically, if you take all of these examples here, those would be irrational. And then all of the examples that we've given that were rational are not irrational. A number is going to be rational or irrational. It can't be both. And these are all under the context of real numbers. So real numbers, you might be thinking real, are there real? Yes, there are imaginary numbers. So real numbers consist of all rational and irrational numbers. So everything that's up above, they're all real. So if something is natural, it's also going to be a whole, it's also going to be an integer, rational, and real number. Okay. A non-example, you might be saying, well, what does something that's not real look like? It's going to have an I or an imaginary component to it. And you will learn about that later in your math career. Let's go ahead and look at the number system. We're going to label the number system with the above terms. So the most basic classification is real numbers. And then after that, we said it's either going to be rational or irrational. So we're going to put rational versus irrational in the next classification. And so rational again would be like 7/5 or 0.72 or 2.16 repeating, whereas irrational numbers are going to be square roots that don't simplify, pi, or numbers that don't really have a rhyme or a reason and are in. A subset of rational numbers is going to be integers. So that's going to be all of the numbers you would normally write on a number line. And notice that in this Venn diagram here, if it's integer, it's automatically going to be rational, and that also means it's also going to be real. Then you're also going to have your whole numbers as a subset of integers. So that's going to start at 0 and going to be infinite in nature on the positive side. And then the smallest subset is going to be the natural numbers. So that's, again, you naturally start counting at 1, so it's all of those numbers. So if, for instance, again, you're talking about 4, 4 is going to be natural, a whole number, an integer, rational, and real. It's going to have a lot of classifications, the most specific of which is the natural numbers. So let's practice some of these classifications. So let's take a look at 27/9. When you look at that, your first question is, can I simplify this? 27 divided by 9 is 3. So realistically, what we're doing is classifying 3. So 3, the first question is it real? Yes. All of these are pretty much going to be real. We're not going to deal with the imaginary numbers. So real is pretty much always going to be the case. Then your question is going to be rational or irrational. Now this one has a concrete number 3. It terminates, and I can write it as a fraction, so it's going to be rational. Then you keep on asking yourself the next one, is it an integer? Yes, because it would be on my number line. It is a whole number, it's not a decimal at all. And it is a natural number because when I count 10, 1, 2, 3, I say the number 3. How about B? So we're going to simplify this. We have the negative sign out in front. 32 divided by 2 is 16. So this simplifies down to -4. So right away, I know it's not going to be natural because it's negative. It's not a whole number because it's negative. And so I only have 4 things to ask myself after this. It is real. It is -4. It can be written as a fraction, so it's rational. And the question is it an integer? So would you see it on that number line there if you were to write it? Yes, you would. Okay, the next one. 4 plus the square root of 13. We ask, can I simplify the square root of 13? Not really. I mean, it's not going to be nice. It's going to be a decimal, which means right away, not natural, not whole, not integer. So now we have these 3 classifications over here. We're going to go ahead and say this is real, and it's either going to be rational or irrational. Because it has that square root part there, I can't write that as a fraction. So that's going to make this irrational. And if something is irrational, it's going to be none of the other ones, the natural, whole, integer, and rational. If it's irrational, it's just irrational, and it's done. Okay, how about D? So it's real. It's either going to be rational or irrational. It is written as a fraction and it doesn't simplify. So it's still going to be rational because it can be written as a fraction, but it's not an integer, whole, or natural number. So the only classifications here are going to be rational and real. 0.125 is real. Even though it's a decimal point, I can write this as a fraction because it terminates. Anything that terminates is going to be rational. It is not going to be an integer, whole number, or natural number because it is that decimal. So again, this is another one where it's just rational and real. Okay, so this next one, we want to order these from least to greatest. So the first thing is to make sure we're going in the correct order. So we want the smallest first, and then to the greatest, so to the largest. So what I'm going to do is I see that there's four numbers. I'm going to give myself kind of four spots here. And I want small to be first and then big to be last. Let me look at these and try to approximate what they would be. I'm going to do this. I'm going to do it without a calculator to see if we can kind of figure things out here. The square root of 1/4. Well, I can take the square root of 1, and I can take the square root of 4. So the square root of 1/4 is 1/2. It's going to be about, not about, it is going to be 0.5. So that one looks kind of large. It's for sure bigger than 0.1 repeating and 0.4. The only other one that we need to compare it to is 1/3. 1/3 is 0.3 repeating. So 0.5 is going to be the biggest one. So what I'm going to do is I'm going to take the square root of 1/4 and I'm going to write what the original problem started as. And that's my biggest number. My smallest number here I can see is 0.16 repeating. And then the other two, we want to go 0.3 would come next. So it's going to be 1/3 next, and then 0.4 after that. The whole goal of this is that they are real numbers. They are all rational numbers. And we wanted to try and see if we can use our number sense to order these rational numbers. So I hope this video helped, and I look forward to seeing you tomorrow.